Hey everyone, it's Justin again. In the last lesson, you learned some important terms for discussing polynomials. So now it's time to put those terms into action. This unit is all about multiplying and factoring polynomials. So we're going to start off by learning the essentials of polynomial multiplication using a visual model to help you understand exactly what's happening. By the end of this lesson, you will be able to multiply monomials by polynomials. To get there, first we're going to review basic distribution. Then we'll expand our understanding of distribution to learn how polynomial multiplication works. And finally, we'll finish off with a few practice examples. First, let's talk about something you already know, distribution. When you multiply one value by a group of values being added or subtracted, the part outside the parentheses gets distributed to everything inside. This is because the part in parentheses is actually one value that's been split up into multiple pieces. So when we multiply by another value, we're actually multiplying the entire part in parentheses as a whole, but it looks like we're multiplying the individual pieces. For the sake of this example, 2 times x plus 5 is 2x plus 10, because both the x and the 5 get doubled as pieces of the whole value. Polynomial multiplication is the same exact concept, just with different looking terms. The best way to see this is with an example. Here we've got a monomial, 2x squared times a trinomial, x squared minus 3x plus 1. We set up our area model just like we would for distribution. 2x squared is only one term, while x squared minus 3x plus 1 is 3 terms all grouped together. Our 1 by 3 area model shows that we have 3 multiplications to do. 2x squared times x squared, 2x squared times negative 3x, and 2x squared times 1. 2x squared times x squared is 2x to the 4th. 2x squared times negative 3x is negative 6x to the 3rd. And 2x squared times 1 is 2x squared. So the product of 2x squared and x squared minus 3x plus 1 is 2x to the 4th minus 6x to the 3rd plus 2x squared. See? It works just like distribution, but with polynomial terms instead of just numbers or variables. Let's do a few more examples to make sure you've got it. 3x squared times the binomial x plus 5. One term times 2 terms. 3x squared times x will be 3x to the 3rd, and 3x squared times 5 is 15x squared. So 3x squared times x plus 5 equals 3x to the 3rd plus 15x squared. If that one was too easy, try this then. 4x to the 5th times the polynomial 5x to the 3rd minus 3x squared plus 2x minus 3. Luckily for us, the size of the polynomial doesn't make this any harder because we're just multiplying term by term. 4x to the 5th times 5x to the 3rd is 20x to the 8th. 4x to the 5th times negative 3x squared is negative 12x to the 7th. 4x to the 5th times 2x is 8x to the 6th. And 4x to the 5th times negative 3 is negative 12x to the 5th. So the product of this polynomial multiplication is 20x to the 8th minus 12x to the 7th plus 8x to the 6th minus 12x to the 5th. That's all there is to polynomial multiplication. It's just like distribution, but it's not always a monomial times a bigger polynomial. It's actually much more common to multiply polynomial times polynomial. That's why in the next video, we're going to expand our area models to more than one row. See you then.